In this section, you're going to be using the blueprint for problem solving in order to solve applications that involve systems of equations. Now, in the past, when we've used the blueprint, we've been dealing with problems that only involve one unknown. But when we work with the problems in this section, you'll see that the problems will have at least two unknowns. And when we have two unknowns, we need to assign a variable to each one. Therefore, two unknowns gives two variables. And when you have two variables, we need to set up two equations that create a system in order to solve that problem. So to review, here's a blueprint for problem solving that represents problems that use systems of equations. So the first step is to read and mentally list knowns and unknowns. The second is to assign variables, and notice this is plural, so it's not just one variable, but one for each unknown that you need to find in your problem. And then you translate that information into mathematical expressions using those variables. The third step is to write a system of equations using the variables you assigned in step 2. Step 4 is to solve this system from step 3. Step 5 is to write your answer in complete sentences. And step 6 is to check your solution. So let's try a couple examples. Here's our first problem. It says, one number is 3 more than twice another. The sum of the numbers is 18, and we need to find the two numbers. So using our blueprint, the first step is to read the problem, which we've done, and then we need to list in our minds the knowns and the unknowns. So out loud, let's talk about it. We know that the sum of two numbers is 18, that's a known. We also know that one of the numbers is 3 more than twice the other. So we can use that information and write some equations. So step 1 we've done. Step 2, we need to assign some variables to these unknowns. So let's assign the variables x and y. So each represent one of our numbers that we need to find out. Now we can use these variables and translate the rest of the information into a few equations. So we can say that x plus y equals 18 because the problem says that the sum of the numbers is 18, so x plus y is our sum. We also can say, using the first sentence, one number is 3 more than twice the other. So we can say that y, that's one number, is 3 more than twice the other. So we have twice x, and then we add 3 to give it that 3 more than. So here's a few expressions here. We have x plus y equals 18 and y equals 2x plus 3. And if you consider these together, these are two equations, we've done step 3, which is to write the system. So this system of equations is what we need to solve for step 4. So looking at these two equations, we can see that the second one is already solved for y. So we're going to use the process of substitution. And we're going to substitute 2x plus 3 in for y in our first equation there. So let's go ahead and plug that in. We have x plus 2x plus 3 equals 18. Then if we solve this equation for x, we can find its value and then plug that back in order to solve for y. So simplifying this left side, we have 3x plus 3 equals 18. And then let's add negative 3 to both sides, which leaves 3x equals 15. Divide both sides by 3 gives us x equals 5. So here's one solution. X is 5. So we plug 5 back into our equation. Let's do the first one here. If we have 5 plus y equals 18, subtract 5 from both sides, and we're left with y is equal to 13. So here's our two numbers. If we move on to step 5, we can state our answer in a sentence, and we say the two numbers that we needed to find are 5 and 13. Now let's do step 6, which we need to check our answers. So let's plug 5 and 13 back into our equations to see if they work out. So using this first one, x plus y equals 18, we can say 5 plus 13 equals 18. Does this check? Yes, 18 equals 18. Woo! Okay, and let's try our other equation here. Y equals 2x plus 3. Let's plug that in. Let's do 13 equals 2 times 5 plus 3. And then simplify. So we have 2 times 5 is 10 plus 3 is 13. And this checks as well. So our two solutions, x equals 5 and y equals 13, work out great. Let's try one more example. In this problem, we're dealing with a boat that takes 2 hours to travel 24 miles downstream. It also takes 3 hours to travel 18 miles upstream. The problem asks us to find the speed of the boat in still water and also to find the speed of the current of the river. So let's use the blueprint in order to find our answers. So the first step was to read and list the knowns and the unknowns, which we just did. The second step is to assign a couple variables. So let's let x equal the speed of the boat in still water. And then we'll allow y to equal the speed of the current. Then using these two variables, we'll write some expressions in order to translate this information into something that we can use. So we're going to set up a table here. We have 2 rows, one for the information for the upstream data and one for the information for the downstream data. And our columns represent distance, rate, and time. So for upstream, we can write the boat traveled 18 miles, and then the rate is the speed of the boat. Since it's going upstream, it's going against the current, so we need to subtract the speed of the current, so we have x minus y. And then the time it took this boat to go upstream is 3 hours. Now for downstream, the boat went 24 miles, and then its rate is the speed of the boat, which is x. Since it's going downstream, the current helps it, so it goes faster, so we need to add the speed of the current. So we have x plus y here. And then the time it took to go downstream was 2 hours. So then we can use these expressions here in order to write our system of equations, which is what we'll do for step 3. So using our distance formula, which is distance is equal to rate times time, we can write each row as an equation. So we have 18 is equal to x minus y times 3. And then our second row is 24 is equal to x plus y times 2. So here's our system, and let's simplify this a bit. So this top one simplifies. If you divide both sides by 3, you get 6 is equal to x minus y. And then divide the bottom equation both sides by 2, you get 12 is equal to x plus y. So here's our system, which we'll now solve for step 4 of our blueprint. So I'll rewrite this up here. We have 6 is equal to x minus y. And then we have 12 is equal to x plus y. Now when we write the system aligned like this, it sets up very well for the addition method. So if we add these two equations together, we can add 6 plus 12 is 18, and then x plus x is 2x, and then negative y plus positive y cancels each other out, so that's 0. Then we solve for x, divide both sides by 2, we get 9 is equal to x. So then we can plug this value. This is our speed of our boat. It's 9 miles per hour. So we can plug this value into one of our equations in order to solve for y. So let's plug it into our second equation here. I'll write it over here. We have 12 is equal to 9 plus y. And then we solve for y. We can say that y is equal to 3. And so we know that y represents the speed of the current. So our current speed is 3 miles per hour. So for step 5, we can summarize this using our sentences. We say the speed of the boat in still water is 9 miles per hour. And the speed of the current is 3 miles per hour. And then step 6, we can just check our values. So in our first equation here, we have x equal to 9 and y is equal to 3. So if we have 9 minus 3, that's 6, and that checks. We can also look again at this equation, our second equation here. 12 is equal to x plus y, If we have 12 is equal to 9 plus 3, we know 9 plus 3 is 12, and that checks as well. So our solutions are accurate for this problem here. So as you can see, the blueprint is a very good tool for helping you work through application problems using systems of equations.